Hi everyone, in this presentation I will explain how variational autoencoders are used to generate realistic human faces. Unlike traditional autoencoders that only reconstruct images, so VAs can generate completely new images by learning the probability distribution of the training data. So this technology is widely used in artificial intelligence, image synthesis and creative applications. So VAE is to generate faces. So variation autoencoders are one of the most popular generative deep learning models. The main purpose is to learn hidden patterns from a large collection of face images and then generate new faces that look realistic. So generated faces are not copied from the dataset but are completely new. So training process. During the training process, thousands of face images such as Select A dataset are provided to the VAE. The encoder compresses each face into a latent representation while the decoder reconstructs the image. Through continuous learning, the model understands important facial features such as eyes, nose, mouth, and overall face structure. The latent space is the most important part of VAE. It stores meaningful information about facial characteristics like face shape, hairstyle, eye color, age, and facial expressions. Similar faces are placed close together in a latent space, making it easier to generate realistic variations. So after training, we randomly sample a latent vector from a normal distribution. This random vector is passed to the decoder, which generates a completely new face. Since the decoder has learned facial patterns, the output appears realistic even though the face never existed before. The figure demonstrates the generation process. A random latent vector represented as Z is given as input to the decoder. The decoder transforms this vector into a realistic human face. By selecting different random vectors, we can generate unlimited unique faces. So these are the some advantages of VAEs for face generation. So they offer several advantages. They generate entirely new faces instead of copying existing ones. Their smooth latent space enable interpretation and controlled editing of spatial attributes. They are also useful for image synthesis, data augmentation, and research in computer vision. An autoencoder mainly focuses on reconstructing the input image using a fixed latent vector. In contrast, a variational autoencoder uses a probabilistic latent space, allowing it to generate new images. Therefore, autoencoders are reconstruction models while VAEs are generative models. So overall, VAEs are trained using large face datasets. They learn the distribution of facial features and use this knowledge to generate realistic faces. Because of this capability, VAEs are widely used in artificial intelligence and computer vision applications. In conclusion, variation autoencoders are powerful generative models. Their smooth latent space enables realistic face generation, interpretation, and facial attribute modification. They are valuable tools for image synthesis, data augmentation, entertainment, healthcare, and many AI research applications. So the concepts presented in this presentation are based on this book, Generative Deep Learning by David Foster.